All right, picking up where we left off on our notes for arc length and curvature, we're going to move into what's called the circle of curvature. So we'd mentioned how curvature and circles interact in the last one, and we said that when you have curvature and you have a circle, the radius of the circle is the reciprocal of the curvature. So what we can do with that is we can actually find what's called the circle of curvature for a graph. So we're going to actually draw what this means and calculate the equation of that circle. So write the equation for the circle of curvature for this curve right here at t equals 0, and we're going to draw it first. So first things first, if I want to draw this vector valued function in 2D, I can take it from a vector valued function into a rectangular equation by first looking at the parameters and then saying, well, if x equals 2t and y equals t squared, that means that x over 2 equals t, and I can sub that in down here for this t, and I'd get y equals x over 2 squared, which is x squared over 4. And that is most definitely something I can draw. So here's x, here's y, and x squared over 4 would be kind of wide-ish like this. And it says we're supposed to draw the circle of curvature where at t equals 0. So at t equals 0, then this would be the point 0, 0. So I want to draw the circle of curvature at this point. What we're trying to find is what circle can nestle itself down in there and be tangent to that parabola. That's what a circle of curvature is it's tangent right there to that parabola, so that the curvature right here at this bend equals the curvature of this circle. All right, so that is what we are going to match up. And it's actually pretty cool. I really like this stuff. It does have some applications to it when you're talking about like gears and the way that, you know, a belt would go around a circle for a conveyor, things like that, but I find this stuff kind of interesting. So anyway, I digress. We need to find the equation for the circle of curvature. Well, I should probably find the radius first, because a circle is nothing without its radius. So I'm going to find the curvature. So my r equation was 2t squared, which makes my r prime, let's see, 2 comma 2t, and it makes my r double prime 0, 2. Oh, and I forgot to add that third component there, so I can do the cross product and use the formula that we've used before. So there's r prime, there's r double prime. So then I'm going to evaluate these at t equals 0, which is going to give me 2, 0, 0, and 0, 2, 0. So k, again, is r prime crossed with r double prime divided by r prime cubed. So r prime crossed with r double prime is going to be 0, 0, 0, 0, 4, 0. So I got the magnitude there, and the magnitude of r prime, well, r prime is 2, 0, 0, so the magnitude of r prime is just 2. So this is going to be 4 over 8, which is 1/2. So if my curvature k equals 1/2, then that implies that r equals 2, because your radius is the reciprocal of your curvature. So if my radius is 2 and my circle's right here, that means that this center point has to be at the point 0, 2, which makes the equation of my circle x squared plus y minus 2 squared equals r squared, which is 4. So if I pull a calculator up here and I do y equals, my first curve is y equals x squared over 4, and then my circle is going to be, let's see if I can do this in my head here, it's going to be 2 plus the square root of 4 minus x squared, and then 2 minus the square root of 4 minus x squared. I just took that equation right here and solved for y. And I'm going to zoom square this. So I'm going to zoom 6 first, and then I'll change it to zoom square so you can really get an appreciation for how good this actually does look here. So you can kind of tell right there, and if I zoom square it, that'll make my pixels an appropriate size so that a circle actually looks like a circle. So there's my parabola, and there is my circle inside, and you can see it's tangent to the parabola. It's pretty cool. So I'll just bring this over here so I can look at it. Oh, it's not going to let me. Anyways, it looks pretty good. So that is that. Now, this gets a little bit more complicated as we move forward here. Oh, look, it did show up. Just didn't want to show me. So the circle of curvature, one step that I kind of glossed over is how did I know the center went up the y-axis? Well, common sense told me that the circle was up on the y-axis. But what if I took something that didn't have a vertical or a horizontal shift to get to the center? I would need to go perpendicularly. So that's what we're going to get to right here. All right, so it says find the curvature to get your circle of curvature, take its reciprocal to calculate the radius, find r prime, use step 2 to create a unit normal vector. That way it points toward the concave side of the curve, and that'll show me where it's going to go. So let me kind of show you what's going to happen here. It's going to be a little bit complex. If you have questions, please let me know. So find the circle of curvature to this point on this curve. All right, well, I'm going to do the best I can here. So I have here x equals 3t, y equals 2t squared. That means x over 3 equals t, which means y equals 2 times x over 3 squared, which is 2/9 x squared. So again, I have a parabola, and it looks something like this. And I want to find the circle of curvature at the point 3, 2. So let's say the point 3, 2 is like right here. This is not drawn to scale, but let's say the point 3, 2 is right there. My circle of curvature now is going to be considerably bigger, and in fact it might be so big that it crosses back over here like this. That would still be a circle of curvature because all I care about is that it nestles into the curve right here. I don't care what happens on the other side. So there's, you know, a somewhat decent circle of curvature, but the center would be over here, so I need to find this perpendicular direction here, that normal direction, to get to my center. So we need to find the radius, find the center, and just kind of go from there. So I'm going to start with the radius and say that r is 3t 2t squared 0, which makes r prime 3 4t 0, and r double prime 0 4 0. And if I evaluate those at, well, wait, I need a t. If I'm at the point 3, 2, if x is 3 and x is derived by 3t, derived isn't the right word, but defined, x is defined as 3t, that means this is t equals 1. So I'm going to evaluate this at t equals 1 and get 3 4 0 and 0 4 0. So k, now if you've been paying attention, when we've been doing all of these, I often end up with cross products that are 0 for my x component and for my y component. And lastly, for my z component, I almost always end up with just this last cross multiplication, if you want to call it that, this last cross product. So this kind of always happens when you turn a 2D vector into a 3D vector. You're only going to have one component left for your curvature, and that component is going to be these diagonals minus those diagonals. But anyway, I digress. So k is the cross product divided by the magnitude of r prime cubed. And the magnitude of 12 is 12, and the magnitude of a vector 3, 4 is going to be 5, and that's cubed. So I have 12 over 125. That is my K, which tells me that my R is 125 over 12. All right, well, I got half the battle. I've got the radius. Now I need to find the center. Well, we're going to use that thing that I talked about before, that nifty trick where if you're in 2D and you have a direction that's tangent, your normal direction is the negative reciprocal of that vector. So a tangent vector is the vector 3, 4, which means a normal vector is going to be the vector 4, 3 with one component negated. Now, since my circle has to come over here, I have to go up and to the left, which means I'm going to negate the x, because I'm going to go to the left. Now, there's my normal vector, but that's just a normal vector. I want to take this thing, negative 4, 3, which points in some direction, but doesn't give me the magnitude I need. I need to make that be only as long as I need it to. I need it to be exactly this long. Well, if I want to turn a vector into a specific magnitude, the rule is I take the vector, I divide it by its own magnitude, and then I multiply by the magnitude I want it to have. Well, I want the magnitude of this to be equal to the radius, so I'm going to multiply by 125 over 12. So the vector that I need, I'm just going to call it V, is going to be negative 4/5, 3/5 times 125 over 12. So what's that going to be? The 12, that's going to leave a 3 here, and that's going to leave a 25 there. So this is going to be negative 25 thirds, if I'm not mistaken. Because I'd have 60, you know what, I don't trust myself. It's early in the morning while I'm doing this right now, so I'm just going to make sure. So 4 times 125 divided by 5 times 12, which I'm pretty sure is 60. It is 60. I'm just joking around here. 8.3 repeating, which would be 25 thirds. Yep. And then 3/5 times 125 over 12, I'm just going to trust myself this time, is going to be 25 fourths. This tells me how to move from the point of tangency to the center. That means I'm going to take the point 3, 2, and I am going to have delta x be negative 25 thirds and delta y be 25 fourths. So I'm going to have 3 take away 25 thirds, 2 plus 25 fourths. Now 3 is going to be 9 thirds minus 25 thirds is going to be negative 16 thirds. And then 2 plus 25 fourths is 8 fourths plus 25 fourths is 33 fourths. And I'm pretty sure I'm right about that. So this is now the center of the circle, and up here I had the radius, so hallelujah, we finally have an answer here. So my circle of curvature is x plus 16 thirds squared plus y minus 33 fourths squared equals 125 over 12 squared. And that, ladies and gentlemen, is circle of curvature. It is not very easy at all. But it should hopefully make sense when you really stop to think about it. So you'll do a little practice, it'll make more sense. And last but not least, this last part is very, very short. This is curvature and rectangular coordinates. We've been doing all that stuff where we've done curvature mostly on 2D because I wanted to do circle of curvature. But when you do curvature on 2D, you can take something and say, okay, I keep doing that same thing over and over again. I get 0, 0, comma something in my numerator because I have to fake a 2D thing into a 3D thing. There's a better way. And that better way is take something that's in 2D, and if it's written in function form, you can use this formula to calculate the curvature. Again, I am not going to go into the whole thing, but it's going to get you there. So if I want to find curvature with something that's a function, I can just do this. I can say, all right, my curvature takes y double prime So here's y prime. Here's y double prime. My curvature takes the absolute value of y double prime. So in this case, it's going to be the absolute value of 6x over 1 plus y prime squared to the 3/2. And then I just take this curvature formula and I plug in the value they want me to plug in. So in this case, at x equals 2, this is going to give me 12 over 1 plus, let's see, that's going to be 3 times 4 is 12 minus 9 is 3 squared to the 3/2. So my curvature is going to be 12 over the square root of 10 cubed, which is 12 over 10 root 10, which simplifies, but I really don't care that much. And just, again, one other way to do curvature. So I'm going to stop talking now because this lesson is now on 17 minutes. So we got to have a joke today. The joke is going to be, what do you get when you cross a snowman and a vampire? Frostbite. I know it's a kid joke. You probably heard it before, but it's frostbite. So there you go. That's all you got. And we will talk again soon. Bye-bye.